Hello everyone, hope you all are doing well. So today we are going to delve into a critical topic in web application security, which is server-side request forgery, also known as SSRF. So let's get started. To begin with, I will just give you an introduction. What is SSRF? SSRF stands for Server-Side Request Forgery, as I told you before. It's a vulnerability that allows attackers to manipulate a web application into making unintended requests on its behalf. In other words, attackers trick the server into fetching resources from internal or external locations that it wasn't intended to access. Moving on, we will discuss how SSRF works to better understand the server-side request forgery. So attackers typically exploit a vulnerable web application by submitting crafted inputs such as URLs that contain specific instructions to fetch data from unintended sources. The application then blindly processes these inputs and sends requests to the specified URLs. Now, why is SSRF dangerous? So SSRF possesses severe risk to web applications, and organizations with SSRF attackers can access sensitive internal resources, databases, or this can lead to unauthorized data exposure, service disruptions, and even full server compromise. It is very much essential to address this vulnerability to protect your application and users. So here is a step-by-step explanation of how SSRF works. First of all comes the user input, so the attacker identifies a part of the web application where user input can be supplied, such as a URL parameter from field or API endpoint. Then comes the malicious input. The attacker provides a specially crafted input that contains a URL pointing to a target they want to access, and this target can be an internal resource, an external server, or any other endpoint accessible via HTTP. Then comes the request generation. So the vulnerable web application takes the malicious input and uses it to generate an HTTP request. The application may not properly validate or sanitize the input before making the request. Afterwards comes the sending the request. So the application sends the crafted request to the specified URL, which could be an internal resource or an external server. Then response handling. The application receives a response from the requested URL, depending on how the application processes the response. The attacker can infer information about the target potentially accessing sensitive data or exploiting vulnerabilities. So later on we have exploitation, which is the final step. The attacker can use the SSRF vulnerability to perform various malicious actions, such as accessing internal databases, interacting with internal APIs, or even performing actions on other external servers. Moving forward, let's discuss some of the examples of server-side request forgery to further illustrate how attackers can exploit this vulnerability. So the first example that we have is AWS metadata access. An attacker sends a crafted URL to the web application, directing it to access the AWS metadata service endpoint. This service provides valuable information about the server's identity, including access credentials, instance information, and security group details. Then we have internal API exploitation. Suppose that a web application allows users to fetch content from external websites by providing a URL. An attacker can manipulate this input to point an external API accessible only within the organization's network. Then the attacker would extract sensitive data from the internal API responses, such as customer records or confidential information. Moving forward, we have cloud service abuse. If a web application interacts with various cloud services, an attacker may abuse SSRF to interact with these services directly. For instance, an attacker could trigger the web application to make a request to an Amazon S3 bucket, allowing them to upload malicious files or even delete important data. Then we have port scanning. An attacker may use SSRF to perform port scanning on internal network resources by sending requests to various internal IP addresses and different ports. They can determine which ports are open and potentially vulnerable to further attacks. Moving on, we have database interaction. So if the web application can interact with databases, an attacker can use SSRF to access and manipulate sensitive data stored in these databases. By crafting a URL that points to the database server's internal IP and port, the attacker may perform unauthorized queries or exfiltrate data. So moving on, we will talk about the SSRF attacks against the server itself. Basically, this causes the server to make a request to the specified URL, retrieve the stock status, and return this to the user. And in this situation, an attacker can modify the request to specify a URL local to the server itself. For example, the server will fetch the contents of the admin URL and return it to the user. Now, of course, the attacker could just visit the admin URL directly, but the administrative functionality is ordinarily accessible only to suitable authenticated users. So an attacker who simply visits the URL directly won't see anything of interest. However, when the request to the admin URL comes from the local machine itself, the normal access controls are bypassed. The application grants full access to the administrative functionality because the request appears to originate from a trusted location. As we have talked about the SSRF attacks, now we will be talking about how can we protect our web applications from these type of attacks. So protecting your web application from server-side requests unfortunately requires a multi-layered approach that includes preventive measures, proper input validation, and security best practices. So here are some of the essential steps to help you protect your web application from SSRF attacks. First of all, we have input validation and sanitization. Always validate and sanitize user-supplied input thoroughly before processing it. Ensure that the URLs, IP addresses, and other data received from the users are well-formed and legitimate. Then comes whitelisting and blacklisting. So implement a robust whitelist of allows, URLs, and IP addresses that your application can access. This restricts requests to trusted sources and prevents attackers from exploiting SSRF by targeting unauthorized endpoints. Also avoid blacklisting as it can be error and easily bypassed by the attackers. Later on, we have restricting access permissions. So apply the principle of least privilege. Ensure that your web application has access only to the necessary resources and not internal or sensitive systems. Then we have network-level restrictions. Implement firewall rules and network restrictions to limit the web application's outgoing connections. This helps you to prevent SSRF attempts against the internal services. Then we have utilize WAF web application firewall. So use a WAF to monitor and filter incoming requests, blocking the malicious requests that may indicate SSRF attempts. Then we also have disable or limit SSRF-prone features. So if your application doesn't need to fetch resources from arbitrary URLs, consider disabling that functionality altogether. Also, if the feature is necessary, then limit the accessible resources to a predefined set of trusted endpoints. Then we have use indirect request. So if your application needs to fetch data from the external URLs, consider using indirect request through a site component. This intermediary component can perform the external request on behalf of the user and safely return the result. Here we also have secure credential management. If your web application interacts with cloud services, API keys, or sensitive data, so ensure proper credential management, avoid hard-coding or exposing sensitive credentials in the application code, or regular security audits and penetration testing. So always conduct regular security audits and penetration testing to identify and remediate SSRF vulnerabilities and other security flaws. Afterwards, we have educate your development team, train your development team about the risk associated with SSRF, and provide guidelines on secure coding practices. And lastly, we have implement content security policies, which we also call as CSP. So use the content security policies to control which external resources your web application can request. CSP helps you to prevent unauthorized access to sensitive resources and mitigates the risk of SSRF attack. By combining these preventive measures and best practices, you can significantly reduce the risk of SSRF vulnerabilities in your web application and enhance overall security. Always remember that security is an ongoing process, so continuously monitor and update your security measures as new threats and vulnerabilities emerge. Now let's see how can we identify SSRF vulnerabilities. Identifying server-side request forgery vulnerabilities requires a systematic approach, combining both manual inspection and automated tools. So here are several methods to help you identify SSRF vulnerabilities in your web application. First is manual code review. Perform a thorough manual code review of your web application source. Look for instances where user-supplied import such as URLs or IP addresses is being used to make external requests. Pay attention to functions or methods that initiate network connections, as these are potential points of vulnerability. Then comes URL input analysis. Identify all places in the application where users can input URLs such as in parameters, headers, or cookies. Analyze how these inputs are processed and whether any checks are in place to validate and sanitize the input before making request. Then comes test with valid URLs. Attempt to use valid URLs in the application's input fields to verify that they are processed correctly. This includes both external and internal URLs. Verify that the application handles expected URLs appropriately without any unintended side effects. Later on, we have test with invalid URLs. Input invalid URLs and observe how the application reacts. Check if it displays error messages or behaves unexpectedly, as this might indicate a potential SSRF vulnerability. Then we have out-of-band techniques. Consider using out-of-band techniques to identify SSRF vulnerabilities. For example, include an external server in the URL and check if it receives any unexpected request indicating SSRF. Then afterwards we have testing with well-known SSRF payloads. Utilize well-known SSRF payloads to test the application for potential vulnerabilities. These payloads are crafted to trigger specific behaviors that could indicate the presence of SSRF. Then comes manual testing of boundary values. Manually test the application with boundary values such as IP addresses that are considered internal or restricted. Observe how the application processes such input and ensure it does not allow unauthorized access to internal resources. Then we have fuzzing and automated scanning. So you can use fuzzing techniques to input a wide range of random or malicious values into the application's URL parameters and check for unexpected behavior. Automated security scanners can also help you identify potential SSRF vulnerabilities in your respected web application. Then comes test for cloud metadata access. Specifically test for access to cloud metadata services like AWS metadata by using typical URLs associated with those services. Verify that your application cannot read sensitive cloud resources or retrieve sensitive information. Then we have check third-party components. Examine any third-party components or libraries used in your application for known SSRF vulnerabilities. Stay updated with security advisories for these components. And in the last we have monitor logs and network traffic. Continuously monitor application logs and network traffic for suspicious activities or any evidence of unauthorized request being made to internal or external resources. So by combining these techniques you can actively identify and address SSRF vulnerabilities in your web application, thus improving its security posture and protecting sensitive data from potential exploits. Remember that security testing is an ongoing process and regular reviews and assessments are very much essential to keep your application secure over time. Let's talk about the manual code review for SSRF prevention. Manual code reviews during the development phase can help identify SSRF vulnerabilities early on. Certainly, let's walk through some examples of manual code review techniques for preventing server-side requests forgery vulnerabilities. So the first example that we have is input validation and whitelisting. Consider a code snippet that takes a URL from a user and makes an HTTP request to that before being used in the request. Ensure that the user input is properly sanitized to prevent injection attacks. Consider implementing a whitelist of allowed domains or IP addresses to prevent SSRF attacks. The second example that we have is URL redirection handling. Imagine a scenario where a URL is provided by the user and then followed through redirections. Examine if the application properly handles redirects when following URLs. Ensure that the final URL after redirection is properly validated and whitelisted. The third example that we have is DNS resolution vulnerability. In this example, user input is used to make a DNS lookup. Analyze whether the user input is properly sanitized and validated. Ensure that the application checks the resolved IP address against a whitelist of allowed IPs. Later on, we have collaborative reporting. So collaboration between developers and security teams is crucial. Evaluate the integration of security logic within the codebase. Ensure that the security checks and logics are properly documented for future reference. Always remember the goal of these examples is to demonstrate how manual code review can help identify potential SSRF vulnerabilities. During the review process, you will want to examine input validation, whitelisting, handling of redirects, DNS resolution, and any other relevant factors to prevent SSRF attacks effectively. Always consider the specific context of your application and its architecture while performing the code review.